The session probably will be studying about flexible automation, right? So you have a lot of automation strategies and all, but flexible automation is more related with group technology and how grouping can be done. So what is the biggest advantage of grouping? All those things we'll be learning, and apart from that, we'll be learning about cell design. Like we have already studied in the very fundamentals of this thing in the very first unit, but anyways, we'll have a one more time brush upon the same concept. Flexible automation, automation assembly systems, okay, automatic transfer, feed lines, flexible assembly systems, and at the end we'll be learning about performance evaluation and economics of the assembly systems. So first thing is what is this group technology? What do you understand by the name group? When you I mean, as a word, what will you understand? When you hear the word group, what will you understand? Together. Then any other answers? Any improvisation in the answers? So how do you form a group? A group of people, a group of things, a group of books? How would you like to form?
It's based on some criteria, sir.
What is that criteria? Any one criteria?
Like when we are forming groups for assignments, we choose who we are comfortable working with and who we, that's about it.
Okay, can I put this something like, so like-minded people are together?
Yes, sir.
Okay, then any other answers? What do you understand by group? What is the biggest advantage of grouping things, maybe?
So they have the same basis in terms of comparison.
Any other attributes?
Like they are put like some things are put in.
Okay. Can you group two things like a huge truck and a small car? Both are vehicles, right? What attributes differentiate them?
So but
Guys,
it depends on your basis of the group. So if you're defining your group as vehicles, or you're just defining your group as like heavy vehicles,
so there are a lot of attributes
something related to C.
Exactly. So there are a lot of attributes while deciding up the groups. So we'll have a fundamental definition of what is group technology is. It's a kind of manufacturing philosophy in which similar parts. What do you mean by the word similar? It could be terms of color, it could be terms of size, it could be terms of objects which are being used in production process, in manufacturing process, that are identified and are grouped together to take the advantage of similarities in design and production. What do you mean by similarities? Similarities in terms of, as I said, similarities in terms of, for example, in apparel manufacturing industry, all zips are together because they only vary in sizes but not in shapes. Zipping is more or less the same. Okay, so while you design a fabric, you will choose, okay, a zip size number 10 for an apparel size number 40, let us say. So you have a design similarity there. That means for 40 you have to use this particular zip only. That's the similarity. That's the biggest advantage. Okay, that's the biggest advantage. In both designing and production, it will help you out. Like it will help the personnel who are utilizing it, right? So group technology and to be precise, cellular manufacturing, they are applicable to a wider variety of production situations. What do you mean by production situation? Production situation could be an inline production or maybe a assembly line production, something like that. Okay, so there are certain conditions where GT is more applicable, that we'll see in the later slides, okay, where this group technology is more or less applicable. First one, okay, so where do you apply this GT? GT, there are like multiple things what a company or a production process look into. First thing is there are hurdles that are there in implementing GT, but these hurdles are only at the initial stage, but not at the design or maybe fabrication or manufacturing stage. Only at the beginning stage you have implementation of GT issues will be there. Okay, the very first thing is identifying part families. What do you mean by identifying the part families? Can you tell the sequence of apparel manufacturing? Am I audible, guys?
Yes, sir.
Yes, it's
Yes,
sourcing
sir.
of raw materials.
Raw
Then,
mat-
it goes to spreading section, then
mm-hmm.
cutting section,
Mm-hmm.
then sewing, finishing,
Mm.
and packing.
Mm.
And then it
Folding.
is outsourced to the
Folding and packing. Okay.
retailer.
Okay.
Yes.
Outsourced to the
Yes,
persons,
sir.
right? So in this, what parts are used in which particular thing? If you could identify, first thing is that's only identification. Okay. First thing, as you said, raw material. It has to be unrolled. So you have unrolling machines and cutting machines together.
Yes.
Okay. Yes or no? After that,
Yes, sir.
okay.
Yes,
After that, you have to arrange the pieces which are cut, right? Which are going for sewing. So arranging cell and the sewing cells to be together. Then after that, finishing your buttons, zips, whatever, like your fabric holding technology that is there. You can make the technology, and then after that it will go for folding and packing together, right? So the second line itself says that you arrange the machines in such a way that each production process is according to your part family. That means, as I said, raw material unwinding, that is your unrolling and cutting together, that could be one cell, because unrolling and spreading takes a lot of space. Okay, similarly,
Sir?
cut yeah.
So, what do you mean by unrolling and cutting together, sir? Like, do they have to, like, in what context?
Maybe in terms of space, because if I simultaneously unroll and cut together, that's a saving of time, saving of space.
Yes, sir, but actually, it doesn't happen that way in most industries, sir. Like, they have a completely separate storage room and they have a separate spreading room. First, it spreads and then they cut it. So, it generally happens in two different sections.
Okay,
Yes, sir.
but
And then
can't we integrate them? That's my concern. Like,
yes, sir. Yes, sir. So they can be integrated.
they
Yes.
can be integrated together so that your flow will not be missed out. Like, that means you keep a roll of fabric which will get unrolled or unwinded automatically. Okay, after that the cutting process takes place with the same machine, so it's a kind of integration, isn't it?
Yes, sir.
So that is possible in group technology. So that means I am identifying two parts that are together, because spreading is a different process which always occupies some space. Yes or no?
Yes, sir.
So if I unroll and cut together, that's a kind of space saving, time saving as well, and as well as your in process saving or your complete time saving, right? So I will arrange the production machines, or maybe while implementing GT, I can take this step that I'll rearrange the machines in such a way that it will have multiple attributes. As I said, in this case I am considering the space. Okay, so I'll choose something like there are few people who are joining. I don't know. I have never seen them. Divya Priya or somebody like that. Okay. Okay, I'll arrange the machines into some typical machine cells. That means, as I said, spreading and cutting together, or unrolling and spreading and cutting together. It is being done by 3 machines and 3 different places. Why don't I integrate them, put in one cell? Thereby, your material movement time. You have a material movement as well, right? Guys, are you there?
Yes, sir. We have.
Okay, so
Yes, sir.
can't I save time there? Can't I save space there if I
Yes,
integrate?
sir.
Okay, so GT has multiple advantages, but it will be a bit tough while it is being implemented at the beginning stage. Yes or no? Okay, so two things are there for implementing. First thing is identifying the part families. Second one is rearranging the production machines into machine cells. That means each cell which is dedicated for a particular series of operations. As I said, now I have taken a good example that unrolling and cutting, and then what do you say, transferring the machines into transferring the what do you call dissected pieces into the next stage. Okay, so what benefits you get out of GT? Okay, it has a it has a plenty of advantages for after it is being implemented. First thing is it will promote standardization of tools and fixtures and setups. Okay, for example, I'll give you one more good example. For cutting down a jeans fabric, what is the type of blade or what type of tool you use for that particular thing? As at the same time, for cutting down the linen fabric, what kind of tool do you use? For cutting down the silk fabric, what kind of tool you use? Obviously, jeans cutting cloth tool would be much harder. It would have a different specification. Yes or no? They are operated at different speeds.
So the machine would be same, but the
Machine would be the
RPMs
same.
would be different.
The machine would be the same. It is just like you are changing a drill tool bit. Drill bit I am changing so that I can drill in a deeper hole or maybe a thick, what do you say, different size hole. But here the tool would be changing. Okay, the tool would be changing. For example, if I apply GT, first thing is since I dedicate a cell, okay, first thing it will standardize the tools. That means for jeans cloth, this particular tool only should be used. Unknowingly, if a person who is not properly trained uses the same tool for which is being used for, let us say, silk cloth or something like that, so in that case there might be a chance that it might break if it is being used for a jeans fabric. Yes or no?
Yes, sir.
Okay, so it will standardize for jeans of this particular thickness. We have to use this tool. At the same time, what do you understand by fixture? What do you understand by fixture? In one of the video I have shown that a machine which is actually a CNC machine which has a stitching tool end, okay, or the whole sewing machine end as a moving device. So in that I have shown one particular device which will hold the fabric while the stitching process is going on. Okay, so it's a kind of fixture is a kind of mechanism which will hold your work object while the machining operation is going on. While cutting, for example, I want to optimize the cutting lengths and all. I don't want to lose any particular fabric piece. So in that case, I'll go with a tool which will hold the position of your what do you say, the work object, like your fabric. Okay, and other setups, you have different setups. Okay, so all these things can be standardized using GT. It will promote the standardization. So if you have a good standardization, your tool breakage or maybe tool replacement or whatever the process that happens, it will happen in a very uniform way. Okay, thereby you will get a uniform production. Second thing, material handling is reduced because the distance between the machine cells are much reduced, shorter than within the factory, entire factory. Because we are in the previous example also I have told, somebody was asking a question, sir, how does that matters? Okay, so here you are grouping the machines together. That means everything will be in one cell. So the material movement for one particular operation will not be happening. I'll show you a good pattern of the material movement. So how does it happens in an industry if it is not properly grouped together? And the process planning and production scheduling are very simplified. Why? Any idea? since you are grouping the things together, the biggest advantage is you can estimate what is the process time. Yes or no? You can estimate the process time. So your production planning can be like very much scheduled. So I have already 10 things that need to be manufactured by this cell. How much time it will take for the next batch to come in? You can have an estimation. So thereby you can make a very simplified production planning. But in the previous case, if it is a non-grouped manufacturing layout, what happens? The material movement has to be take place between multiple machines. So thereby the material movement time will be more. Okay. What do you mean by setup time? What do you mean by setup time? Setup times are reduced, resulting in lower manufacturing lead times. What do you mean by setup time? Guys, any answers from you?
So I think setup time is basically the amount of time which takes just to start the production, to set up the machinery or whatever it is,
Okay.
to start the production.
So for example, you have planned for a product. So you know what is the machining operation that has to be taken place in one particular cell. So you can create an order stating that I need these machines for this particular layout. Okay. So you can always have a grouping together. You can always have a grouping of machines together. So thereby what happens is your actual setup time, that means see, for example, after cutting you have to rearrange the pieces. Okay. But if you already arrange the pieces together like one by one as a sequence, you can reduce the setup time in starting the process. Okay. Or as Praneeth was telling, that ordering the machines, etc., even that is also kind of setup time for the thing. But here in this context, it is only related with the material setup time. Okay. So it will reduce the manufacturing lead time. Okay. If you reduce the setup time, thereby ultimately you can reduce the manufacturing lead time. Work in progress, I think I have already it's more or less the same thing. So for example, for a design, from design to manufacturing, if you have a well planned schedule, like cell 1 will produce this particular part, cell 2 will produce this particular. So if you already made a designs according to your cells, okay, according to your manufacturing layout, that will actually reduce the work in progress time. Okay. So the next one is worker satisfaction usually improves when workers collaborate in a GT cell. What do you mean by this? Okay, let us assume that the cell is not automated. So you have a series of operations that has to be done in using 3 to 4 machines. So you have since 4 people are working together in one cell, because there are 4 machines, so 4 operators will be doing the job. So what happens is you have a good worker satisfaction. For example, one guy will produce one part, pass on to the next guy, thereby you will get the finished product of that particular cell. Okay. So you have a worker satisfaction also. Okay, done, I am doing this much job per day. That's a kind of worker satisfaction. At the same time, they will collaborate with each other. Okay, so there is a high probability of ideas exchange, etc. Okay, that is again a biggest advantage. And higher quality of work is accomplished if the cells are grouped together, if the machines are grouped together into cells, or there will be a good amount of improvement in quality, okay, for the work that is being done, because you will monitor each cell rather than each machine or the material movement. What kind of grouping methods that do exist in the current day? Okay, there are a lot of grouping methods, out of which 3 plays a very, very crucial role. First one is intuitive grouping. So this grouping is a kind of experienced grouping. Okay, unless and until a person who is well experienced in an industry cannot group things together. So that's the biggest drawback of this grouping. And second one is the part classification and coding. This is also kind of grouping where you have a huge assembly line. For example, assembly line for a car or a bike, where the number of parts would be in terms of thousands, tens of thousands, etc. And the third one is production flow analysis. This is a kind of hybrid between both. Okay, hybrid between both, but it will always deal about production flow. How does the production flow happens, not the design flow. Okay, so let us move on to the grouping, intuitive grouping. So what do you mean by intuitive nature, or maybe like what do you mean by the word intuitive?
Sir?
Instinct.
Instinct. Then any other answers? What do you mean by intuitive? The word intuitive. I need some answers. Okay, no matter if it is wrong or right, that doesn't matter. Like, you just answer the thing, whatever you understand from the word intuitive.
So it's more like making decisions based on your the vibe you get, like instinct only mostly.
Hmm?
Sir,
doesn't have to be
reflex
real.
response to something.
Hmm? Any other answers? Okay. So, in an industry or in a typical organization, who is the leader? Who is considered to be the leader? Obviously, the head. Yes or no?
Yes, sir.
Okay. So he take intuitive decisions. What do you mean by intuitive decisions? That means he has an experience. He is more or less, he has some good experience. With that experience only, he can take some decision. Okay. The word intuitive here will speak about, like, so if someone feels it to be a true based on his experience, that is called as intuitive nature. Okay. So the biggest problem in intuitive grouping is, unless and until you have some experience in that firm or in the production plant, you cannot group things together. Okay, it's a kind of very less sophisticated method where it is done through visual what do you call, mode of inspection. So segregation of tools, parts, etc. will be done using the part families. Okay, and whatever the person feels will be your ultimate thing of classification. Okay, ultimate thing of classification. But in this case also, there are two attributes on which a technical personnel can categorize the things. One is the design attribute, other one is manufacturing attribute. So what do you mean by design attribute? Classification of parts into design attributes. Can you name a few? Okay.
So,
Yeah, please. Please go ahead.
so design attributes in terms of machine or in terms of the whole setup?
It's just a design attribute, not the setup nor any other thing. So here the parts are classified, or the part families are classified. You are using 100 parts, 100 tools. So in design, how would you incorporate all those information? Which software you use for designing your let us say your fabric designs and all? You use AutoCAD?
Yes, we just started.
Apart from AutoCAD, what software you use?
Tuka CAD.
KukaCAD. CAD.
Yes, for garment.
For what?
So we do pattern making and grading.
Pattern making and grading. Okay. So what attributes you think while you are designing one particular product in that software?
So size,
Dimensions. Perfect.
dimensions. Yes.
Perfect. Apart from that, so I'll give an example of what the design attributes that can exist in a, let us say, fabric or maybe apparel designing. Color is one design attribute. Shape, size, dimensions. Okay, which part has to be placed at what position. Okay, in certain models, in certain maybe you take any typical apparel, your buttons are on an offset, they are not exactly at the center. Yes or no? You might have seen such designs like that. So what is that offset that you have to use to place your buttons? Okay, so for example, your cuff length, your hand cuff length, or maybe your shoulder length, all these are design attributes. Your length of the shirt, all these are design attributes. In certain shirts are very tight fit. Okay, that's a design attribute. Yes or no? Do you understand what is a design attribute in this particular context? Okay, any such things if you could name where design attribute should be considered, like a kind of design attribute should be there. Guys, are you there? What do you understand by a manufacturing attribute? Okay, in manufacturing attribute, more or less you use a lot of tools. For example, if I am going for a thicker cloth or maybe a size which is higher, generally what you use, you choose a different machine rather than a different tool. Okay, because you have a lot of problems. Your when it becomes to an inline production, the machine shouldn't stop. Okay, so smaller machines cannot take up such a huge load, so you choose a machine which is capable of doing that. Apart from that, you use certain tools. For example, for sewing up the jeans cloth, you use a different needle, different thread. That's a manufacturing attribute. Okay, so according to your design and according to your manufacturing attributes, your grouping is done. You understand the manufacturing attributes? Guys, are you there?
Yes, sir.
Okay, so so manufacturing attributes at times they vary, but more or less it can also be standardized. Okay, manufacturing attributes also can be standardized. Okay, what do you understand by this figure? How does this figure look like?
Well, it's very confusing.
Very
It's a-
clumsy search.
It's not organized or ordered. Like
Okay,
it's
okay. So here all the machines are grouped based on machine type, but not on the process or the typical production type. Okay, so here in the first block you can have a look. In the first block, lot of turning machines are there. Second block, lot of milling machines are there. Third block you got drilling, fourth grinding, and fifth as assembly. Can you find how many number of arrowheads that are there? What is the significance of arrowhead here? Here the significance of arrowhead is more or less like the movement of the material. Okay, so it is heading from one machine to the other machine for machining operation or maybe typical operations that need to be performed. As most of you guys have told that it is not at all organized. Biggest drawback is material movement cannot be tracked, right? And there is a lot of waste of time in material movement. Yes or no? And since they are not organized according to the cell layout, what happens is material movement time will be more. That is actually the useless time. Okay, that is actually more useful time in production. We use a lot of machines that require a nominal material movement. Yes or no? Okay, now the problem is if it is not organized, what happens is your production planning cannot be done. If it is not organized according to your production flow, it is not organized, and moreover there will be a lot of time waste which is not being tracked here. At the same time, you cannot estimate what is the time taken for each product. At the same time, it will become tougher for production planning. So since the organization of machines itself causes this problem, we'll adapt the cell layout. Okay, have a look of this figure. It's a grouped figure, like grouped machines. So you got a machine materials that are received on a bay, and different materials has been supplied to different processes: turning, milling, and drilling, assembly. In the second process, it is milling, drilling, and grinding, assembly. See, the process sequence is varying, but it is well organized. Yes or no? Okay. Only at the receiving and shipping only you got a common platform. Thereby you can estimate the time taken by each machine to complete the process. You can estimate the process production planning. At the same time, you can estimate what is the time that has been taken for one product from raw material to your shipping process. So there are multiple advantages that do have in group technology, and moreover it saves a lot of time in material movement. Yes or no? You understand, like what is the difference between your regular plant layout, or maybe this is also organized, but the problem is it is organized in terms of type of machines but not on process flow. Yes or no?
Yes, sir.
Okay, let us see an example of intuitive grouping. Okay, so intuitive grouping, you have some part design attributes and part manufacturing attribute. Okay, first thing is you have an external shape, it is a major process. Internal shape, which is a minor process. Okay, rotational or regular shape, it is an operational sequence. Length to diameter ratio, it's a major dimension. So there are certain attributes in between designing and manufacturing. I want everyone to make to use this table. Okay, so identify what is the process that being used. Okay, first thing is the question is identify any process in trouser making and segregate them according to their design and production attributes. Okay, can you name a few apart from the things that are put in the table?
So in production attributes, maybe we can include the packaging.
Okay.
Include fabric inspection. So
Okay, I would like to add inspection. But how does that is a production attribute? Is it? That is not producing actually. That's a kind of testing.
It's checking. It happens before the fabric roll is supplied to the
before and towards the end of the whole production also
Yeah.
it happens.
Okay, inspection prior to start of machining. Yes or no?
Even it happens during the process and the end also. So once the garment is made, they
Okay.
have to inspect it. If it
Okay, fine. Okay, at both the ends. Okay, so I'll explain like what attributes that I have chosen as an example for intuitive grouping is. First thing is you are planning to make one trouser or maybe a set of trousers. What design attributes you choose? You choose first thing is material selection. Okay, so which material should I use for production? That's a design attribute. It's not actually, so it is both. In case of production also it's a primary attribute. In case of design also it's a primary attribute, because according to the design attribute, the material selection is primary thing, because your thickness, your texture, okay, all these things really matters. Yes or no?
color also, sir.
All material has different properties like color, texture, thickness, okay, all these things together. So I have put a common word, material selection. So material has these attributes. Okay, so it is an attribute of production as well. Okay, keep this in mind. And what is the second attribute? Size. How do you choose? How do I choose the size? right? So your market requirement is, for example, a lot of numbers in L, because that's an average size that most of the people wear, if I am not wrong. Small XL and double XL are the sizes which are rarely used, so market demand for them will be obviously less. Yes or no? Okay, so it's based on the size of the batch. For example, L I should produce more, so I have to concentrate more on L because there's a huge production in that when compared to M, and so maybe like M is also more or less a good thing which runs in the market. And you have a typical fashion part in that is your bell cut, bell bottom, or maybe a straight fit, tight fit, ankle length, etc. All these things are very much required in design but not in production. And number of individual components, how many pieces should I make? If I make less number of pieces, that's a good sign, because your production process will take less time. Yes or no? Okay, am I correct?
Yes, sir.
If the number of pieces are very less, your production time also will be very less. Okay.
Yes, sir.
And there are other attributes like pattern, style, okay, additional components that are need to be added on the trouser or whatever it is in order to make it fashionable, right? Second thing is the production attributes. In production attributes, what components you would like to look? Your tool type, needle, cutting tool, and other accessories that are required for doing that particular design process. Already designed process, how should you use? How should you take it? Okay, how should you manufacture it? The next one is your tool and your batch size and number of one size, etc. Like one particular size. Okay, how many numbers should I produce? L I should produce 1000, M I should produce 300, XL I should produce 10. Okay, so if the production time is larger, okay, if the production time is larger, that means you are making lot of manufacturing things in that. That means, for example, you take a XL sized trouser, because of the size is very more, okay, size is very high or more, it would take a huge amount of production time when compared with the S small size trouser, because here you use a lot of less amount of the material. Okay, so depending upon the size also your production time varies. Okay, large it will take more, smaller one it will take less time. Okay, and different stitch type, what kind of stitches I should make, different machines that I use, and somebody was stating inspection. So all these are production attributes. Is this intuitive grouping clear for you? In the context
Yes.
of your one example that I have mentioned, that is a trouser making. Okay, next one would be part coding and classification. This is a kind of well organized thing where it will consume most of the time, because for so it cannot be applied for a industry which is smaller, like a apparel manufacturing industry. This can be applied where you have more amount of parts that has to be assembled together. Okay, that are assembled to be together. Example for this is your car manufacturing. Car might have 1000 parts or maybe 1 lakh parts. Okay, certain cars do have a lakh part together. So in order to address each and every part, okay, you have to make a part coding. That means each part will have a specific coding. Okay, so the coding, I think you might have studied in some other subject as optis coding or something like that. It is more or less similar to that. Have you studied optis coding and all? Part coding?
No, sir.
No, sir.
Okay. So it is a kind of system where you have to implement that into 3 groups or 3 methods. Okay, grouping methods. So why you should code? First thing is design retrieval. What do you mean by retrieval? For example, in plant process, you will not be given with a lot of things. You will be given with a paper and a design and some codes on it. Okay, what does the operator understands is through the codes only. That means he would look into the design, find out what is the part and find out where it is available. That's it. And for example, if you want to do some modifications in the design itself, okay, so the best example for this is, I'll take one automobile. Have you seen a car which is made by Tata, which is Tiago? Okay, and the next the successor version of it is Tigor. There are two cars which are more or less similar. Or I'll take a good example like Swift, Maruti Swift and Maruti Swift Desire. Both cars looks the same except for the back space, that the dicky part. Okay, so what is the major change they have made in the design? Only addition of the space. Okay, the space for storage. Yes or no? All components within the car would look the same, but when it comes to the rear part only, the design changes are there. Yes or no? There also you have parts which are slightly modified. So for getting a second product, you need not to worry much. Only thing is you have to change minor modification. So the original design will be same, and in the same design you will add more components. Yes or no? Okay, it is applicable for apparel industry as well. Okay, so earlier bell bottom trousers were more popular. Later it came to straight fit, etc., etc., right? What design component in the same thing you have to modify? You have to remove the bell bottom and make it slightly converging. Yes or no? Guys, are you there?
Yes, sir.
Okay.
Yes, sir.
So that's a kind of design
Yes,
retrieval.
sir.
Okay. There you have to use the codes the most, right? Automated plant process process planning. This is more self-explanatory, where if you want to automate the production process, so your robots don't understand the human language; it understands the code. Okay. So robots will have some stacking of the components which are need to be assembled. So it will scan that component, it will go there, pick the part and assemble it. That's it. So that is one good advantage where you have to code. Okay, that is the reason as well. And the third one is machine cell designing. What do you mean by machine cell designing? I have told no in the previous example. Each set of machines are grouped together, which is called as a cell. Okay. So when you want to design a cell, a whole cell, it is based on your design only. But your design has an attribute of coding. So the coding and the designing would be in par with each other. That means like they are both are like kind of what do you call dependent on each other. Your machine cell designing and your part coding are dependent. So that's the reason you have to go for a coding. So classification of coding. How do you classify the three things? There are three attributes where you classify. First thing is a systems based on the part design attributes. I have already told in the very first where you apply the coding and all. It's based on the part design attributes. Second one is systems based on the part manufacturing attributes. Third one is systems that are based both on design and manufacturing. The best example for this is your material. Third example. So material selection should be incorporated in the design and as well as in the manufacturing, because thickness, for example, if in a fabric the primary factor is thickness for sewing. If I don't incorporate in design, there will be some issues with the sizes. Yes or no? So there will be some addition of length, or maybe addition of the what do you say, waist length or whatever that are there in the trouser. But here this attribute has to be made in both design and manufacturing, because while manufacturing also I should use a particular tool according to the thickness, according to the texture. Yes or no? So these are the classifications of coding. So so we have just now discussed upon like what is the classification of coding and all. So now we'll move on to the next part, which is structures used in coding. So the very first one is the hierarchical structure. That's a monocode that you have where it will tell you about the hierarchy of what is the instrument, like what is the part. For example, If it is the machine as a whole, that's a huge stuff, so it will be given as a priority 1. Okay, just like fabric as a whole, it will be given as a priority 1. The small components like buttons, okay, additional embroidery, whatever those things that are additional components, that will be given as a next code, okay, next level code. Okay, so hierarchy on top, whichever parts which are in bulk in size will be given as the primary code. Okay, because of the see, for the chassis only all parts are attached, so chassis will be given the highest priority or highest hierarchy. But this is not very useful code. It is limited to a number, okay, not more than like triple digit. Okay, so 999 you can give as the highest thing. At the same time, you have a second type of structure called as chain type structure. It's a polycode. That means you have a combination of alphabets, numbers, whatnot. Everything will be there, and you can get an n number of combinations. Okay, but the problem with the chain type of coding is you should have some code representation structure. For example, AB1204, something like that. So it should be well defined. Okay, and the third one is a mixed mode structure, which is a hybrid code, where it is a combination of a monocode and a polycode. Okay, it would look something like AB1032, ABAC12 something like that. So each code, each particular segment of the code will have a significance. First thing is you have a look of this 5 code segments. Okay, 5 code system, which I have taken it for explaining like how does a code system look like. So the first code is B31. That's a basic shape. For example, you take sheet metal that you are planning to form it into a culinary utensil. Okay, so first thing is your basic shape, that's your flat disc, where after that some forming operation has been, punching is done. After that it will be checked for size. Okay, then for the precision. So B3123-A1, it's the code which is a mixed mode code, where it got a combination of letters, alphabets, etc. In certain cases some special signs also might be used. Okay, so these codes are very essential if and only if your system is very complicated. Okay, system itself is very complicated. Am I audible to you?
Yes, sir.
Okay, great.
Yes.
So production flow analysis. This is a kind of approach where Dr. Burbidge has formed it. Okay, so he is a renowned pioneer in making some production analysis and all. And this guy has identified part families and associated machining groups. For example, bolt has to be manufactured by a lathe alone. Okay, so that's grouping. Punching can be done by using one sheet metal punch alone. So like this he has managed production families, that is part families associated with the machining groups, right? So first thing, how do you perform this production flow analysis is, first thing is data collection. What data you collect? Okay, data that is collected with respect to, first thing is part families. How many part families I have? For example, in a company there are 1 lakh part families. Okay, 1 lakh part families, not the parts. So in that, how would you select machines according to the parts? So let us say 2000 parts are being manufactured by one machine. That's part and associated machine groups. Okay, so for example 10 machines are making these 2000 parts. So these 2000 parts will come into one set of machines, let us say 5 machines. Okay, so that's the first thing. Second, this is pertaining to data collection. What is the speed of your machine for this part? What is the material removal rate for this part, etc. All these things are segregated together and collected as a data. Second thing is sortation of process routings. What is this process routings? How does this part is being manufactured? Is like through some series of operations, yes or no? So the process routings are sorted. That means after grouping the machines, it will be sorted according to the process. Okay, so first lathe, in the previous example also I have shown no sortation of process routings. Just to have a look here, the machines are sorted according to the process. That means turn, mill and drill, drill and grind. Okay, so but the assembly point is same, yes or no? Here the process is being sorted according to the manufacturing requirement, but not on the design requirement. Okay, after this The second one, the next one is cluster analysis. Cluster analysis is way advanced version, where you clusterize multiple machines together. That means, you know what is a cluster is? Cluster is different data sets that are being grouped together. Okay, what do you mean by different data sets? Speed is one data. Okay, machine type is one data, and then what is the material that is being used is one data. Material removal is one data. What is the thickness of the material is one data. So all these data together is called as cluster. Okay, one cluster, and you perform analysis related to each and everything. That becomes a cluster analysis, right? So you can have a look of like how does the production flow analysis would more or less the tabulation would look like. So here the machine or operation will have code, that is cutting off using 1, lathe using 2, turret lathe using 3. So each machine will be given a code rather than a process. Okay. So in PFA chart you have multiple things, right? Your machine 1, okay, just have a look of this. Okay, machine 1, okay, machine 1 is manufacturing part A 1 part, part D 1 part, part H 1 part. Okay, so like this your machines are sorted according to your parts, right? Machine 7 is producing part B and F and G. So your machines at times machines if they are very heavy, grouping them will become a very tough job. Okay, in that case we can go for incident and part machine index. So this index would tell which machine is performing which parts. Okay, so you will get much data on both of a combination of both of this. Okay, so thereby you can plan your production also, like, okay, so that's the biggest advantage of production flow chart. Okay, your production flow analysis. Later we'll move on to the cellular manufacturing. What do you understand by cellular manufacturing? What is basically a cell is? Can you have a look of the figure? Can you have a look of the figure that has been presented in the slide and tell what do you understand by the cellular manufacturing?
Sir, it happens in order and as soon as possible.
Okay.
Like it's not wasting time anywhere.
Okay. Any other answers?
So it happens in one particular compartment and
okay,
by an optimum process.
Okay, it happens in one particular confined cell. Any operation that happens in one cell. Okay. Any other answers? Praneeth? Harita, any answers from you?
No, sir.
No idea about cellular manufacturing. Kashish? Any other answers? Okay. Barnana, you have any answers for what do you understand by cellular manufacturing?
Sir, I think in cellular manufacturing, the product movement is faster, I think, sir. I think in this product movement from one machine to the other machine is faster.
Okay. So faster movement of materials. Okay. At the same time, your production rate also will be high. All the machines are grouped together. So material movement time would be also low. Okay. Any other answers pertaining to this? Shweta? Sukesh? Apart from the other answer, you have any other answers? Ashwati?
Sir, I think the process also happens in a specific order.
Exactly. Okay. There is a sequence of operations. Okay. Any other answers from you? Okay. So cellular manufacturing is a combination of machines that are put together in one particular place to perform a sequential operations. Okay. To perform a sequential let us have a definition of this. So cellular manufacturing is an application of group technology in which dissimilar machines or processes have been aggregated into cells each one which is dedicated for a production of part or a product family or a limited or families to a limited number. Here it's an application of group technology to what? To your production, where your materials, your machines which are dissimilar in nature, that means no machine should match with other machine, that in terms of its production performance. Okay, at the same time these are aggregated into what? Into a cell. Okay, into a cell or cells, okay, depending upon the size of production. So which can dedicatedly produce one particular part or a group of parts or a part family together. Okay, so this is a very very generic definition, but how does the cellular manufacturing look like and what objectives it got? Let us have a look. The very first objective is to reduce or to shorten the manufacturing lead times by reducing the reducing the setup. Okay, your setup time is already reduced. Okay, and your work part handling is also reduced. That means your work part handling time is basically reduced. Okay, so waiting time is also at the same time reduced because it's a sequential process. Okay, it's a sequential process, and you can shorten the number of batches as well, or batch sizes as well. Okay, or you can increase based on the requirement. But what is the biggest drawback in the very first objective? What do you mean by waiting time here? For example, if one machine is processing one particular part which is moved on to the next. Okay, so for example, if the first machine itself is not properly manufacturing the thing and it is being fed into the second machine, it will give a defective product. At the same time, it will lead to the breakdown. Okay, that's a primary problem in case of the sequential processes. Okay, or batch processing, or maybe your manufacturing cell. But if the machine is breakdown, you cannot replace the machine as a whole. You have to bypass. Okay, so in certain cases there will be some standby machines if the size of the machine is small. Second objective, to reduce work in progress inventory, smaller batch sizes, shorter lead times, and reduce work in progress. What is the first thing? Work in progress inventory. What is that? What do you mean by working? Am I audible, guys?
Yes, sir.
What do you mean by work in progress inventory?
Sir, work in progress is nothing but like the amount of quantity that is left from the starting point to the ending point, sir.
Any other answers? Work in progress is like, for example, 10 machines are manufacturing some product. If it is being manufactured at one particular machine, let us say 4th machine, still it has to pass 6 machines in order to get the finished product. Yes or no? Okay, I think Praneeth has given such a good answer. That means it's an continuous addition to your product in order to make it a finished product. Okay, or in monetary terms, what does it means is total value of the materials, okay, or the labor for unfinished projects or unfinished products. How much labor we have put in, how much time we have put in. Time is also a kind of matter, okay, money matter. Okay, at the same time, how much material, that is a raw material or inventory. So that is work in progress inventory. Okay, so it also reduces that. It also reduces the thing. Okay, that's a secondary objective. What is the tertiary, or there are a lot of tertiary objectives. That is the first one, which is improve quality. Okay, improve quality of what? Of the product. It can be accomplished by allowing each cell to specialize, okay, in producing a smaller quantity of different parts. This already we have discussed in the previous video lectures and all. We have discussed much on this. That means each product is of different type, of different quantity at the same time. Okay, but it is smaller in number. There is a variety of product. Okay, that we have already discussed. So this will reduce the product variability. Okay, process variability. Sorry, this will reduce the process. What do you mean by process variability? For example, 10 apparels you are producing. Each apparel is taking 5 minutes, let us say. In between certain set of trousers are taking 6 minutes. There is a variability of 1 minute for 2 fabrics. That's the process variability. Okay, so uniformity of your process can be obtained. Okay, second thing is to simplify production scheduling. Okay, what is this production scheduling simplification? Any idea? What do you understand by production scheduling simplification? You got an order. How long it will take to start the production? Immediately? Okay, on what factors that depends upon? Raw material, labor availability, and then machines, okay, or the process that is available with us. Yes or no?
Yes, sir.
Okay, if the raw material and machines are available, only thing that is left over is your production, right? So your production scheduling, if it is a well organized cell manufacturing layout, it can be reduced to a very nominal extent. That is, it can be reduced. So the amount of time taken to start the production will be very nominal, very less. Okay. Similarly, you have lot of complexities in production scheduling. For example, I said no material availability. So if material is not available but your machines and labor are available, that means what? That's a typical process where you have to consider upon the materials as well. Okay, so that I don't want to discuss now. So apart from that, you have reduced in setup times. So all these typical cell layouts will reduce setup times, because for starting up the process, setup time will be very, very nominal. You have the raw material very well processed and it can be fed into the machines, so the production process continues. Okay, so how does this can be achieved? This can be achieved by different techniques. The first one is that you group the tools together, fixtures or jigs, whatever the work holding devices that are together. Okay, so this in this way you can reduce more or less the setup times. Okay, you select a particular tool for a particular process, thereby your setup time can be reduced to a greater extent. How do you design a machine cell? Okay, first thing is it is classified into lot of things. First one is your assembly cell, part cells. Okay, according to a number of machines and materials used in turn classified into as single machine cell. That is based on the number of machines that are there in a cell. It's a single machine cell. Group machine cells with semi integrated material handling. That means you got a material movement also there. Flexible manufacturing cell, that is using your robots and additional technology, right? Okay, so how does a single manufacturing machine cell look like? Okay, you got you got a separate machine which has a tool storage. Okay, it's a kind of turret arrangement, and it's a CNC machine. Let us assume it got a spindle, and it produces each part based on the specification that is given in the program, right? And after finishing the program, your parts are kept on a pellet. Okay, that's a kind of material handling system, but problem is it is not an automated material handling system. Okay, there is no automation here. Okay, the problem is here with single manufacturing cell, whatever the materials that are being fed to it, okay, it takes a lot of time. That means next process that has to be taken care, okay, will be on holding. Okay, at the same time you can produce a different variety of parts, but the number of part production will be less because one single machine is acting here. And each part is scheduled. That means your program, whatever that is there in the CNC machine, will execute in a sequential way. That is, one program has been finished, okay, next program will execute on next part, something like that. So what do you understand by this figure? Guys, I need some answers.
Sir, the setup is in such a way that it reduces the time and all the processor.
Okay.
The setup is in such a way
First, for example, yeah. What is the process that is being done there? Any idea?
So is it packaging?
Okay, it is something related with food.
Okay.
It is definitely with food.
I think cookies, sir.
Exactly. Kind of cookie manufacturing only. But what is happening there? Isn't it a sequential process? Yes or no?
Yes.
Yes, sir.
Isn't
Yes,
it a
sir.
sequential process? So what is happening at the person who is wearing a blue shirt, blue color dress? That's the initiation of the process. See, I have taken this as an example because there are a lot of things that you can find in a figure. First, he is preparing something, that is the dough premix. Okay. After that, that is being transferred to the person who is wearing a white shirt. Okay, where your particular part is being processed, that is your cookies are being processed, cut down, spread, rolled down. Okay, the third person is actually doing some additional things like adding up some toppings to it and packing, and the things are being stored in a bin. You can just have a look. There are some breads that are being stored in the bin. Okay, so they have finished one batch of bread, then they are moving for the second batch, something like cookies, right? Here in group machine cell, what happens is you have multiple machines that are organized together. Okay, there might be a material movement through manual process or maybe through automated process, but in most of the cases it's a non-automated process. That means material movement will happen from machine to machine using some manual process only. So people has to be there. Okay, and apart from that, what else you observe in the figure? Kashish, can you have a look of the figure?
Yes, sir.
Yeah, what's happening there? Apart from whatever been discussed now, what has been happening there?
So, can't clearly. So they're packing, like it's they're finally packing the cookies, and so I guess that's what happening, is it?
Okay, see, packing is one process. It's not just other thing. See here, it's a sequential process. Can you observe? If the primary person who is wearing the blue shirt, if he doesn't make the dough, what happens? The next process of cutting down, spreading, etc. will not happen, and at the same time, the
Yes,
third
sir.
process of baking would not happen. In group machine cell, since it is very sequential in nature, the biggest drawback is process initiation should happen at a very instantaneous time. Okay, else whole sequence will be lost. Okay, and there will be good amount of human interaction because it's a single group cell. Okay, there will be a good amount of human interaction. So this typical cell is a U structured cell, isn't it? It's a U structured cell. Okay, so most of your answers
Yes,
are more or
sir.
less correct. There are some additions to it, except for that everything is correct. Okay, and you have at the end of your group machine cell you have a bin for storage. Okay, that's a temporary storage. Okay, there's a temporary storage. Okay, so the last one is a group cell with a semi material handling. Okay, first one is your work in, that is in the first figure you can visualize it's a linear movement where your machines are being placed at 4 places, that is your 4 processing machines are there or processing units are there. So after finishing each part, what happens, it will move on to the next process. Okay, or all processes might be the same. Okay, all process might be the same in certain cases. Okay, so for better quality or better quantity production, you will go with multiple machines with the same process. Okay, so your material handling unit will transfer out the work, whatever the work that you make it. Secondarily, the two things that are placed on the bottom and the right side are what do you say, cyclic motion. Okay, where your work in and work out will be happening on the same conveyor belt or a material handling system, and your production process will be in between. Okay, so the structure might vary, but it is more or less the same. Okay, so the drawback of the last two is like if finished goods are being transferred, that's a waste of time and waste of energy. Okay, so there should be some arrangement that should be made in such a way that there will be a bypass movement of the conveyor belt or maybe the material handling system, where on one particular pass you have semi-finished goods or finished goods, and the second one will have finished goods. Okay, second one will have complete finished goods, right? In that way that problem can be avoided. So the next one is your flexible manufacturing cell. Just have a look. We'll have a flexible manufacturing cell. This is a typical thing where you got a robot. Okay, and can you tell what is been happening here? Any idea? See, there are two lathes. Okay, on both the ends there are two lathes. Okay, one single robot is actually stacking the finished products. Biggest advantage of flexible manufacturing cell is that you have multiple lathe machines, but your material handling unit is fully automated. That means you need not to worry about the material handling. But there, in the semi-finished good transfer, or maybe group cell with a machine cell with a different material handling systems. Okay, here it is manual. Okay, here it is semi-automatic or semi thing. But in this case, you don't have to worry about what is been happening with the material handling. So the robot has the capability to understand what kind of material is it. Okay, whether it is a finished product or whether it is a raw material. Loading and unloading machines is also being done by a robot. But only thing you have to monitor in this case is whether the process flow is correct or not. That means, for example, 10 parts you have given as a program, 10 programs to the CNC machine. CNC machine will execute one after the other in a sequential manner. But the robot has to place the parts according to your program sequence. So your program sequence has to be taken care in such a way that robot also do understand the program and feeds the appropriate raw material into the CNC machine for programming. Clear? Okay, so we'll start with automated assembly units. Okay, so it is kind of mechanized. We have already seen this in the very first unit, but anyways we'll give a full-fledged information on this. So what is the use of mechanized or automated devices is that in assembly lines you have different tasks. So in order to fulfill all your tasks, we'll go with a automation. And we already know one thing is a fixed automation, other one is a variable automation. Okay, so in fixed automation, most systems are more or less like limited. That means you have a process that is limited process. That means you have a good example of Coca-Cola bottle filling. Okay, So you have a bottle and you have your liquid which gets filled, bottled, and at the same time it is cap is inserted and then it is labeled. That's it. That's a simple process. But you can have a bulk of amount in case of fixed automation. We have already discussed this. But in case of variable automation, it is not possible, right? So let us discuss this automated assembly lines fully. The first thing is, where do you apply this automated assemblies? Okay, where there is a high product demand and stable product design. What do you mean by high product demand and stable product design? Good examples for this. Can you name a few? Can you name good examples of high product demand? One particular product where you have high product demand throughout entire day.
Shorts, sir.
See,
shirts, undergarments.
Undergarments, and then apart from apparel industry, can you please name a few?
So right now, face masks.
Face masks,
Footwear.
but it's not a stable product design. Once corona goes off,
Daily use products
what do you mean by that? Be specific.
like
Chargers.
toothpaste and soap and all.
Toothpaste has a stable product design. Okay, so it's a
Yes,
very
sir.
daily, very much required day to day. Then
That's soap, detergent.
soap,
and all.
detergent, these are very high, these are high product demand products, and it got a stable product design as well. Okay, then any other products? I want something related with day to day utilization, which is very much required.
Wheat flour, rice.
Wheat flour, rice, these are also
Sugar.
very stable products. Okay,
Sugar,
having high
water.
product demand. Any other products which doesn't depends upon the market much, which has a stable design, very stable product design?
The things like chair and table also, it's always there.
But you purchase once in life, or maybe once in 10 years, or maybe 5 years. These doesn't have a high product demand. Everybody cannot afford a chair and table. But if they can, but they will purchase once in a while, not regularly. Sugar, tea, coffee, milk. Okay, somebody was telling wheat flour. All food items, okay, except luxury food items like chocolates or whatever. Most of the food items are having high product demand. The best examples somebody was stating, rice, wheat, okay, wheat flour, okay, all these things, milk, tea. These are daily consumed. These are consumed on daily basis. Okay, no matter whether you have money or not. So you will purchase them under, like, maybe you take some loan or something. You get it from the shopkeeper and later you pay once your salaries are deposited, whatever it is. But these are having high product demand. Okay, where it got a stable product design. Milk packets are also good examples. Okay, here you can automate a lot. You can have an automatic packet filling, automatic milk packet filling. Okay, and even rice bags are fully automated. Then the next one is assembly consists of more than a limited number of components. What do you mean by this statement? No more than a limited number. Your production limit is not there. In that case also you can produce. Okay, you can still produce. What is the shelf life of milk? On an average, what is the shelf life of a milk?
1 day.
Maximum, not 1 week. If it is a Tetra Pak, you will have like 10 to 15 days. But on an average, if it is a packet milk, a normal standard milk, it won't last for 2 days. Yes or no? Am I audible, guys?
Yes, sir.
Okay. So the average shelf life itself is how much? 2 days. So within 2 days you have to consume it under any circumstances. Once it is consumed, you will look for the secondary packet or secondary thing. Okay. So in that case, your consumption is also actually high. Okay, here why I have stated this statement is your production does not have much impact on the consumption, right? Your production does not have direct impact. Can you name one good example for this? Even Coke is the best example for this. Coke has a shelf life of almost like 22, maybe a month or maybe 2 months. Okay, so these are produced well ahead. There is no limitation on the product number. Okay, and the last point is product is designed for automated assembly. What do you mean by product is designed for automated assembly? What do you mean by that?
So generally, when we see in these food manufacturing units, they tend to like not have human touch in that. They feel like it might contaminate or something. So
Okay.
they always prefer machines.
Okay.
Like even in advertisements, they showcase that.
Okay. Can you name a few products which cannot be automated, but still they have a high product demand and stable product design? Can you name certain products where they cannot be automated or they cannot be processed through automation?
So like chargers can, like the design keeps changing, right?
Which one? The chargers? Which charger?
Yes, sir.
The phone charger?
Yes, sir.
Okay, but it can be automated. All the PCBs that are there in that can be automated. I am talking about products which are having high demand and stable production. Okay, but you cannot automate it because it has to be made manually.
Sir, pots.
Okay, pots cannot have a high product demand during winter season. And it is not a stable product design. Your pot sizes are not standardized. Somebody make a huge pot, somebody make a small pot, but it does not have any standard size. Okay, to some extent it is okay, fine, we can consider. Even pottery is also nowadays fully automated. Your culinary utensils, all these things are now clay made. They are automated. Can you think of some foods which you cannot automate but still it is having a high product and a stable design? Very hard to find. Okay, I don't know whether this product is having a stable design, but you know the product, the food that is jaggery. Jaggery, it is nowhere automated. You take it anywhere in the world, it is not at all automated. It's a manual process. Guys, am I audible to you?
Yes, sir.
Okay, and it is having a stable product. It is having a stable product design. That means for this much jaggery, this much amount of sugarcane juice should be taken. Okay, it's a stable product design, and it is having a high product demand, and it is having a good shelf life, but it is not still automated. No matter whether it is packing or whether it is production, whatever it is not automated till now. Okay, because the process is like that. Okay, you cannot just like that make jaggery. Jaggery production is a huge process. It takes a lot of time. Okay, it consumes a lot of time. Okay, so that's one good example. Can you name few examples like that? Your nursery products, okay, your nursery products cannot be automated. You take small plants, okay, they have a stable product design, but I don't know whether they are having high product demand or not. They have certain product demand, okay, at the same time they cannot be automated. So these are some examples where it got some application characteristics where this automation production line can be implemented. Okay, what products can be automated? As I said, alarm clocks, light bulbs, okay, clocks, locks, ball bearings, ballpoint pens, mechanical pencils, PCB assemblies, door mechanisms, small electric motors, wristwatches, fabric weaving, stitching, gearboxes, fabric dyeing. All these things can be done using a automated process, even bottling, etc. So what kind of assemblies you make in case of automated thing? Okay, adhesive bonding. What do you mean by adhesive bonding? You use this in fabric what do you call apparel manufacturing also. Can you name one good examples for adhesive bonding?
So sticker fusing.
Sorry?
Fusing the stickers.
Fusing the stickers, okay. You have some on frocks and all, your baby frocks and all, for designing purpose. You generally go with what? Go with some flowers, okay. All these flowers are sticked onto your frock or whatever it is. Yes or no? So that is using some typical glue. Okay, such kind of bonding is called as adhesive bonding, where you can use that. Insertion of components. What do you mean by insertion of components? What do you mean by insertion of components? That's an assembly process, automated assembly process. What do you mean by insertion of component? Do you have any idea?
No, sir.
Okay. So you have, see your zipping device, you have a zipping device, yes or no? So zipping device is inserted between two zipping things. Okay, that's a kind of insertion, where you need not require any other locking mechanism. It's a zipping. Okay. Best example for this is zipping. Placement of components. Have you ever seen a PCB board, printed circuit board, in your electronic devices and all? Even in your cell phone you might have seen. Okay, you can see a lot of components that are not man-made or that are not placed by human. These are made by some typical robots which are very tiny in sizes. Okay, and at the same time you have some components in your apparel manufacturing also. You have to place it in this distinctive location. For example, buttons. Distance between the two buttons and the button holes should be uniform. That's a kind of placement operation. Okay. Riveting is joining two metals or two materials using some typical intermediate thing called as rivet. Okay, you drill it, insert the rivet, and then fix it permanent. That's a permanent joint. Fastening, screw fastening. Okay, stapling, stitching. Stapling can be used in case of most of the interior manufacturing. For example, sofas and all the fabrics are stapled together. Okay. Stitching is also a very good example. Snap fitting. You know what is a snap fitting is? Snap fitting is nowadays used in most of the automobiles. Okay, and even your plastic based devices. For example, your front bumper in a car is actually fitted using a snap. So there will be interlock mechanism. Okay, when you release the lock, you can take it out actually. Second, the next one is soldering. This is done mostly in the PCB components. Spot welding. It's a welding process. Okay, so all these things can be automated in an assembly line, right? Using automated process. So you have some system configurations in it. That is inline assembly machine, dial indexing machine, carousel system, single station assembly cell, etc. Okay, so before going to that, we'll take some short break, like 5 to 10 minutes, and we'll come back. Okay. Session, we are there, and we have already seen these systems in the previous classes, but I'll give another insight. So you have some different configurations of these automated systems, which is inline assembly system, where the assembly happens within the line, and at the end of the line you can get a finished product. The second one is a dial indexing machine, where the indexing of the objects or the parts will happen one by one based on the requirement. And the third one is a carousel system. Carousel system is more like, it's a repetitive thing, just like your repetitive conveyor belt, that is a cycling conveyor belt. And the third one is a single station assembly cell. Single station assembly cell is very simplex version of the same thing. And all the things together, single station assembly thing is very bulky in nature, and it has a lot of complexities in it, but at the same time in certain cases it is more or less like very simple. Okay, let us have a look into the inline assembly machine. So in inline assembly machines, you have a series of automatic workstations that are located along the inline transfer system. That means your transfer system will be inline, your assembly systems will have the inputs, okay, the components that are added at the stations, and assembly process happens. Once the object is finished, it will pass on to the next machine, or maybe it could be a series of machines where all the things are added together. Okay, all the things are kind of assembly. So the quantity really matters in case of inline assembly machines, where you got the production rates, okay, which are very much required, which are high at the same time. We can go with inline assembly system. Biggest advantage is your material transfer system is inline, so you need not to worry about the material transfer to the next machine through a typical other system. Okay, so your machines are aligned with your transfer system. That's the biggest advantage. Okay, and it is again classified into synchronous and asynchronous. What do you mean by synchronous? What do you understand by synchronous? Harita, any answers from you?
So could you tell me again the question?
Synchronous machine. Any other? Barnana, what do you understand by synchronous machine?
I'm not so sure.
Okay. You can still give an answer, whether it is correct or not. Let us have a look.
Like some machines work like it has a particular synchronization, like after one after another.
Okay,
So,
one after the
about
other.
that.
Yeah, exactly. One after the other. You can have a look. So once the assembly 1 is finishing, it will go to the next assembly, and so on. Okay. So unless and until your assembly 1 is giving an output to the conveyor belt system or the work transfer system, the transfer will not happen. Okay, that is synchronous. Asynchronous means irrespective of the machines, this movement will be there. Okay, that is very simple. If the output of the machines is synchronized with the conveyor belt, that means it's synchronous. That means it should give an output, then only the transfer will happen. Okay, irrespective of the machines, if the transfer happens, that is asynchronous. Am I correct? Did you understand the concept of synchronous and asynchronous work transfer? Okay, so let us move on to the next one, that is dial indexing machine. Dial indexing machines are used whenever you want typical assemblies, okay, that are to be transferred to the machines, individual machines, in an indexed form. That means one performs and the second one will be fed. Okay, biggest advantages is in this case is like once the operation is finished with the first machine, immediately the part transfer will happen to the second machine, and it is limited to it is always size limited. You cannot go with the larger production lines. It is always, there is a limitation on the size. At the same time, it is very much synchronized. That means one operation can be done only in one way. Okay, that means one assembly unit can perform an operation, then only it will move on to the next assembly. Okay, meanwhile that assembly unit will do another process. Okay, once the assemblies are completed, it will exit out of the dial. Okay, exit out of the indexing dial, and then it is fed to packing or something else. Okay, or secondary process. So the periphery of the dial is fed, it will have an index or a groove sort of arrangement that will do the purpose. Okay, so how does a realistic machine would look like is something like this. It is from Bodine Corporation. You know like what Bodine produces. Okay, so it's basically a pharmaceutical production agency. It produces a lot of drugs. Okay, so here this type of indexing machines you might be seeing in a lot of laboratories where each sample is collected and then processed, dial type machine. Okay, so it's a very small machine, but it can do the job within the specified time limit. I have already told you about the carousel system. Carousel system is a kind of hybrid between your circular and a dial indexing machine, where your finished parts, your raw material is actually fed to the input of it. So your conveyor belt is more cyclic in nature. In most of the cases, this is a dual rotary. That means finished parts will be moving on to one particular machine, one particular conveyor belt, and unfinished on another conveyor belt. But in most of the cases, this is a synchronized workflow. Okay, so assembly 1 finish, then it will go to the finishing of assembly 1, it will go to the assembly 2, and so on. The biggest advantage is this can be fed into a very tiny space limit. That is within a small room also you can have a carousel system. Okay, but in case of carousel system, the major drawback is if the conveyor system is not dual type, or maybe a dual type transfer system, you cannot go with that. Okay, just be online. Tata College working day. System is very huge. Okay, you cannot take this. For example, a car or maybe a rail engine. Okay, all the parts that are required to assemble are fed to it. See, single station work cell I have already shown to it. But the biggest drawback is you cannot make the completed part completely mobile on a simple conveyor belt system. You require complex cranes. Okay, so at times a robot is used for single station cells, but in most of the cases, if it is a continuous moving line, for example, for bike manufacturing, they use this. Bike base engine chassis will be given and assembly will be happening. That assembly will have a constant velocity, that it will move, but at a very low velocity it will move. Okay, because it's a huge bulk component. So within a specified time limit, all the assembly should be done and it will be sent for testing. So that's all about your typical thing, but we'll have some comparisons between multi-station and single station work cell, assembly line. So in multi-station work thing is, it is very fast, it has a very good cyclic rate, high production quantities can be possible, more operations are possible, more components can be assembled. But when it comes to single station assembly cell, you have it is suitable only for robotic thing. Okay, robotic work cell. At the same time, it is used for lower production quantities. Okay, not the higher production quantities. You have a lower production because your material handling system is not so fast. It is just a single robot which is managing all the things. Okay, so we'll move on to part delivery systems. Okay, this thing we have already seen in the very first unit, but I'll give you some detailed information about it. In typical part delivery systems, we have part delivery systems that are there, which is a hopper. You might be seeing this hoppers in your floor mill. Your floor mill, on top of the thing you have a hopper arrangement where the material is being fed, and the material is being fed to the grinding discs. Okay, so where a lot of material is stored, and the transfer of material is through gravity in this case. Part feeder. Okay, part feeder is basically from hopper how you feed the parts. But this is in most of the cases this is also a gravity system, but in certain cases this hopper system and part feeder system together are combined, and this part feeder system is fully automated. That is, you have some mechanism that will transfer the parts. Okay, and selector or a reorienter used for orienting the parts. For example, if you want to stitch buttons, okay, your fabric is fed and your machine doesn't know what is the orientation of button. Location it knows, but the orientation is really a big matter. So in that case, you have to go with the orienter. Okay, and the next one is basically the feed tracker. Okay, feed track means what? it will move the parts to the work head. What do you mean by work head? Is something like in a feed tracker, the biggest thing what you have to understand is like after feeding, after putting the part onto the object which is supposed to be assembled, you have to track its position. Okay, you have to track its position. So the position tracking is maybe a linear or a rotary, depends upon the system. So the feed tracker purpose is to continuously monitor how it is being transferred or how it is being placed on that particular location. Escape and placement, it will remove the parts from the feed track and then places at the station. That means once it is assembled together, so this thing will actually place the component onto the surface of the machine in order to do the process. Okay, we'll have a deeper discussion on this. One thing is part delivery station. In part delivery station, you have a hopper. Hopper you understood from the figure, like you can understand in the previous sessions also. So it is a gravity based thing where the materials are fed and it will select a particular set of materials. Okay, that's a selector. And feed track will actually identify what is the material movement, how the material is being transferred from hopper to your escape and placement cell to your work carrier station. In this example, it is purely a gravity thing. Okay, but in case of certain things which are not non-gravity based things, okay, you have to actually track the movement. It could be a mechanical tracking or a non-mechanical tracking. Okay, and after the materials are being fed from the escape and placement cell, it will move on to your work carrier station, and work carrier station will hold the device and the work process will happen. The later one is a vibratory bowl feeder. Okay, so it is basically, it will look something like this. Okay, in the previous class also I have explained much on this. Whatever the components that are placed will actually pass on to the feed tracker and it will be given as a outlet. The purpose of feed tracker in this case also is, it's like it will monitor how the tracking is being happening, that is how the movement of the material is being happening. So on bottom you got a supporting feed and a base, and you got an electromagnet. This magnet will create some vibrations when it comes into contact with the electrical coil, and the bowl is actually vibrated with certain frequency. Based on the frequency, the material movement will be there. So it will look something like this. Okay, it's a synchrone bowl feeder, where you can see on the bottom you got an electromagnetic coil and a permanent magnet, which will oscillate based on the input voltage frequency that you give. Okay, or input voltage you give. So you got a feed tracker on the edges. So these typical products or maybe the things are being transferred to the outlet, and each one is counted by one typical counter unit. There is a sensory system here. So based on the vibration, the material movement will be there, right? Selector or a orienter. So the purpose of this is to place the components into the assembly workhead. Okay, and it will establish a proper orientation. What do you mean by proper orientation? For example, you just check this machine. So here assume this as a button. So a lot of buttons are placed and they are placed randomly, and there is a wiper blade which is used for orienting the object. Okay, it will be used for orienting the object. Once the objects are oriented, then only you can actually drop onto the place where you can stitch or do something. Okay. The next one is the orienter. I mean, the purpose is more or less the same. Orienter will do the position orientation, but the selector will have a cutout. Through this cutout only the output will happen, or it will just eject the objects outside. I think feed track I have given multiple examples. You have a gravity and powered. In powered feed tracker, it will uses a vibration, air or a typical vibration. So in case of bottle packing, you have a feed tracker which is air powered. Okay, I'll show a video upon that. And escape and placement devices are more or less like a dial type of indexing devices are used. you got a rotary table, and this rotary table will feed the objects into a feed tracker, okay, or maybe vice versa. In certain cases, feed tracker will feed the objects into the rotary table. So both, see, this typical arrangement is used when you want a bottle capping or something like that. Bottle capping is the best example. And you have vertical devices. There is a stack of components where each component will drop. This is used especially in biscuit manufacturing or maybe some food manufacturing where you have a pellets, okay, pellet sort of arrangement. So let us have some videos regarding this, and we'll discuss upon the escape and placement cell later on, like the next after the video description. So this is a vibratory bowl, okay. Here the component transfer is happening, but certain components are getting dropped off, okay. Whatever dropped off components that are again being transferred. What is this device? Escape and placement cell, okay. That's a kind of escape and placement cell where the excessive components are being given away out, okay. So here the first orientation is being happened. That means each component will move in a particular sequence. Here there is a laser thing which will check whether the object is placed in a proper position or not, okay. See, unwanted, see whenever there is a component which is rejected or maybe not properly oriented, is being rejected by a air gun. See, you can visualize a small air gun here. Okay, there is some tube inspection that has been happening there, for example for size. See, when there is a blockage, there is some automation that happened, like when there is a blockage, when there is a production stop, so the whole vibrator bowl device will get stopped because there is an interlock. So here there are two robots where each robot is actually doing a particular operation. So you can see a rotary indexing table here. It's a kind of what is this type of assembly called as? Can you tell? All the machine tools are coming to one particular point. What is this type of assembly called as? The last one, it is called as what assembly? Single station assembly cell. Okay, it's a single station. Folding, bending, and then cutting down. Okay, all operations are being carried out in one go. In real time, it would look something like this. There are different tools. Okay, so all are synchronized. So these are some more linear to rotary to linear motion controllers. See, such a tiny objects which are getting manufactured. What is the bottom thing? Can you just check? I have discussed in the very first unit. What is the bottom component?
So the tool tracer.
Not the yeah, the bottom component which is black in color, which is actually transferring the materials. No, what is that called as? In the very first unit we have discussed that. Rotary table. What is this mechanism on? See, you can just visualize some mechanism on top. This one. This mechanism is a cam mechanism. Okay. What is this thing? It's a laser cut. Okay. It's a plasma or laser cut. Generally, it's a laser cut. Okay. The central position is a tool holding device. Your machine has the movement. Okay. It's such a huge motor. Here the welding tip is being connected with the robot. Kind of spot welding. This is a CO2 laser. Okay. See, it got two different tools. Okay, one is this is a kind of welding tool. That one is a CO2 laser. So you can use a welding and a laser cut for both the things in one robot. Like, what is this operation called as? Can somebody tell? That is called as buffing. Okay, so robot automated buffing. So it's a finishing operation. So whatever you have seen earlier is a tool management system. It is transferring multiple tools. So it's a miniatured version of the same thing. Forming machine. Okay. So these are some examples where you can implement a robotic assembly lines. You have a spring blade arrangement where in the bottom. Okay. So whenever the work carriers are basically the components which will carry, just like your material transfer system. Whenever that is been hitting this component, the spring blade escapement, okay, whenever it hits while moving, one component or one part will be fed into this. Okay, so this component will be transferred onto your work cell, or maybe your if it is a finished product, it will be transferred to the finished station. Especially these systems are used where you have surface on top which is flat in nature. Okay, that makes it suitable. So you have a feed track for transferring these objects. Okay. So you have escape and placement devices which are controlled by pick and place mechanism also, where your parts from the feeder are fed on to your work carriers. Okay, it's a kind of linear robot or linear end effector device, or maybe your linear device which will transfer both in linear axis, both vertical and horizontal. But here you have a rotary thing. Okay, linear and rotary thing together. Okay, where it lifts off and then place it onto the position. So what quantitative analysis you will be looking for the assembly system is part delivery is the primary thing. Second thing is multi-station assembly machines. Third one is single station assembly cells, whatever that are being there, and partial automation. So all these components are suitable for quantitative analysis, but